A study on Sheikh Yasir bin
Each one of
Salman
us is now
Highway.
electronically connected to the globe, and yet we feel alone, said Dan Brown. Traffic engineers are meant to design a path which connects point A to point B, while taking into consideration the efficiency, safety, and the economical sides of the journey. Our study would like to test all these points and state a conclusion from civil engineering students' point of view. Shaykh Isa bin Salman's selected segment is located between two main intersections. One of them is a trumpet and the other is a full clover leaf. The segment is actually longer than 2.5 kilometers with a speed limit of 120 km per hour. As a matter of fact, this particular part of the highway includes 3 lanes for each direction. This highway connects Al Jafar with Tubli towards Bugoua, Sar, and Janabiya, including villages and areas in between. In this case study, we're going to focus only on the segments specified in the maps. We had to obtain measurements of the median, lanes, and shoulders. For that, we used Google Earth just because it's more convenient than using an old. Using data collected earlier, and with the help of AutoCAD, we were able to turn the actual highway into a scale drawing. The 1:1000 scale drawing shows the 16-meter median, followed by a 2-meter shoulder, 3 lanes 4 meters each, and another 3-meter shoulder for both directions. We also prepared a manual sketch of the top view, and here we used a scale of 1 to 200. So our test will consist of 3 main phases. Phase 1, collecting speed and volume data for 15 minutes. Phase 2, finding the average speed in free flow conditions of 62 cars. And finally, Phase 3, finding the level of service for both directions of the segments.
The speed samples were measured in free-flowing conditions ranging from 61 km per hour for heavy trucks in the right lane to 119 km per hour for cars traveling in the fast lane. Speed samples were measured using an app called SpeedGun, which requires the distance from the object being measured as well as a steady and quick hand to obtain an accurate reading. The volume was counted manually for a duration of 15 minutes from 5:25 to 5:40 p.m. 100 vehicles were counted, which were predominantly passenger cars, making the flow rate 400 vehicles per hour per lane. For Phase 2, a speed sample of 62 cars was measured in free-flowing conditions, meaning that the speed of the vehicle is not affected by traffic or density conditions. The average of speed was 103.6 kilometers per hour. These speed samples collected are used for the speed spot study. In the frequency distribution table, speed groups were set to fit the lowest to highest speed measured with a constant interval of 5 km per hour for each group. To help model the data as a normal distribution, one speed group was added to the beginning and another at the end. S is the middle speed, found as the average of the lower limit and the upper limit of each group. N is the speed count, and the frequency is the speed count for each group as a percentage of the total. Cumulative frequency is also calculated. The mean X-bar of the sample is 103.5, and the standard deviation is equal to 11.9. The standard of error was calculated and is equal to 1.5. The standard of error, capital E, is calculated and is equal to 1.5. The plots of the bell-shaped frequency distribution graph and the S-shaped cumulative frequency graph are seen. From the frequency distribution graph, the peak of the curve is the most repeated value, the mode, and is equal to 107.5. The pace is the 10 mile per hour or 16 kilometer per hour range, which covers the highest percentage of drivers and is 98 to 114 kilometer per hour. Since the frequency distribution data was considered to follow a normal distribution, a chi-square test is conducted to check for normalcy. The data was set up in the table as shown. In this test, the theoretical frequency represents the frequency that would occur if the data was perfectly normal. The test is only valid if the theoretical frequency for each group is 5 or more, so groups with a smaller theoretical frequency are combined. The chi-squared value is calculated as the sum of the chi-squared of each group. The degrees of freedom is n minus 3, where n is the number of groups after they are combined. The probability of the chi-squared value is interpolated and found as 75.85%, a value greater than 5. Hence, the initial assumption of normalcy is justified. In the third and final phase, the peak hour traffic for both directions was manually counted in 10-minute intervals with 5-minute breaks. These values were expanded to find the 15-minute flow, and then the peak hour factor for each direction was calculated. The percentage of heavy vehicles was 9.54 for the eastbound direction and 14.58 for the westbound direction. The demand flow rate for each direction is calculated by substituting values into the equation as seen on the slides. The values were compared to the maximum service flow rate for each level of service from the table, and the LOS for each direction was determined. The eastbound direction operates at LOSC and the westbound direction at LOSB. We consider these levels of service to be acceptable considering the volume is for what is expected to be the peak hour traffic on the segment. It is also worth mentioning that this part of the study was conducted during Ramadan and the current situation of COVID-19, so peak hour traffic during normal conditions may differ.
Human errors exist. Thus, our conducted tests are not 100% accurate. For instance, there might be a percentage of errors in the applications used. Also, since we are students lacking experience, we must admit that the tests might have not been done professionally. Another significant matter affecting our study is the fact that it was conducted during the COVID-19 pandemic period, plus it was Ramadan's holy month, which resulted in an obvious change in the traffic normal flow. Finally, we have to state other errors such as the angle of observation. We chose a high place to observe. Few observations might have not been recorded. The weather nowadays in Bahrain, it can get as hot as 36 degrees Celsius during peak hours, and that much of heat can definitely loosen our focus, resulting in more errors. And then there's interruptions. During one of the tests, and although we were standing somewhere far and safe, a policeman did interrupt us to check what we were doing and if we were having any issues. Coming to an end in this case study, and as someone once said, the road to success is always under construction. Similarly, Shaikh Isa bin Salman's highway will also reach a point that requires development. Indeed, to adapt with the larger demand, a project development of rainwater drainage network and adding a fourth lane has already happened in the segment connecting Salmaa to Tubli, which was not a part of our study case segment. Yet, our segment might require going through the same process eventually. And this is not a problem because meeting the expectations of the public is one of the traffic engineer's tasks. And that highway was constructed based on that fact.